Good afternoon, everyone. We're just going to give everyone a few more minutes to jump on. We'll give everyone a couple more minutes. All right, we'll go ahead and get started. Thank you everyone for joining today's webinar. My name is Tiara Rahman and I'm the Director of Professional Development for BOMA, New York. I'll be your host for today. So if you have any technical difficulties, please send me a private message in the chat. We welcome questions throughout today's webinar. However, we will be answering them at the end. Feel free to drop your questions in the questions box in the upper right-hand corner of your screen throughout the day. And with that, I'll hand it over to Tom.
Well, good afternoon, everybody. Before we get started, just by way of introduction, I'm Tom Layden, working for Environmental Building Solutions here in New York City. A little background on myself, in case you're wondering who the heck is this guy giving this presentation on Legionella. I have a degree in chemical engineering from Polytech Institute in New York. I worked 13 years out in the chemical and food industry and joined Nalco Water, worked for Nalco Water for 23 years before I joined Environmental Building Solutions in and currently with them for 9 years. So that's a little background on me and why I know some things about Legionella. So with that being said, again, welcome everybody, and here's some of the things we want to talk about today. What is Legionella and why is it a risk to buildings? Are there any laws or regulations concerning this? Should you test for this? If you test for this, what are corrective actions? We'll actually go over 3 case studies that we were involved in. Will there be any future regulations? What is a domestic water safety plan? And we'll finish it with questions and answers that you guys submit in the chat. Okay, next. So what is Legionella? Legionella is a rod-shaped gram-negative aerobic bacteria. If anybody's taken high school biology, you always used to do a stain, with it turned purple, and this happened to be gram-negative, which is an aerobic bacteria, which means that it likes to live in oxygen. It was first identified in 1976 at an American Legion conference where 29 people died. It causes Legionnaires' disease. Although Legionella, there are 60 different species of this bacteria. However, the majority of the human diseases are caused by Legionella pneumophila serogroup 1. Again, like I said, there's many different types of Legionella, but the one that's most risk to humans is Legionella pneumophila serogroup 1. This bacteria is able to survive. Wait, just go back one slide. The bacteria is also able to survive at a wide range of temperatures, and we'll get to that in a second. Okay, next. So it's a waterborne bacteria. It's in mist. It is everywhere. Soil, natural water, so coming from reservoirs, lakes, and it can come into your building with the New York City supply. To thrive in water, it requires the right growth conditions, including warm water, organic nutrients, and other bacteria. Now, here's a very, very important part of this presentation. To pose a health risk, a Legionella has to grow and then be aerosolized so people can breathe in small contaminated water droplets. That's how we people contact Legionella. Another important item here is that you can contact the disease by drinking water that contains the bacteria. So if this bottled water has Legionella, I'm fine. Legionella is not contagious. Okay, so if somebody has Legionella, your neighbor can't get it, your wife can't get it, and it's not contagious. Okay, next slide. The bacteria, once inhaled, affects the oxygen transfer in the lungs. Very, very similar to what we all experienced a few years ago with COVID. Just like COVID, also, the disease tends to affect people with compromised immune systems, elderly people, smokers, asthmatics. People with really weak immune systems tend to get this disease if they're exposed to it. So this is an important, very important slide here. What temperature does Legionella grow at? So you see below 66 degrees, it's not likely to grow. Does it mean it's present? It can be present, but it could be a dormant stage, okay? The ideal temperature for growth is in that first section there, which is 77 to 120 degrees. As we get above that temperature, it tends to die. You see that above 122 degrees, 90% kill in 2 hours. Above 140 degrees, 90% kill rate in 2 minutes. And above 158 degrees, 100% rapid kill. So why are these temperatures up there? 120 degrees is sometimes what we like to see at faucets, and 140 degrees is what we like to see sometimes out of hot water heaters in commercial office buildings, okay? So where in the building is Legionella risk? So any place in the building where water is stored, heated, or transferred. Some examples include hot water heaters, storage tanks, showers, hot tubs, pipes, valves, and fittings, infrequently used equipment, including eye wash stations. Yes, even eye wash stations can contain Legionella. Decorative fountains, and last but not least, is cooling towers. Okay, now we're going to go into some of the laws and regulations concerning Legionella. Next slide. New York City and New York State both have regulations concerning Legionella in cooling towers. And believe it or not, New Jersey will soon be adopting very similar legislation. There are no current regulations for Legionella in potable water systems in commercial office buildings. So you can't get fined by the DOH by having Legionella in your domestic water system. However, there are regulations for testing water in New York State healthcare facilities. This includes hospitals, nursing facilities, any place where medical work is being done. those people have to test regularly Legionella in their domestic water systems. So what happened here? So local law 77 was adopted in 2016, and that mandates the regulation of cooling towers. And you have to have a management plan, testing, et cetera, 90-day testing, 3 times a week testing to minimize Legionella growth. Laws will soon be in effect in New Jersey for similar regulations like I just indicated. There are no New York City or New York State regulations for Legionella risk management for domestic water in commercial office buildings, as I just indicated, but there are regulations for New York State healthcare facilities, okay? New York City Local Law 77, well, this was the big one in 2015 with Mayor de Blasio. 13 people died due to Legionella. The source of this outbreak was traced to a cooling tower in the Bronx, and people may ask, well, how did they determine that? Believe it or not, it's from the lungs of the people who were deceased. The Legionella bacteria was identified, and it was the same bacteria serogroup that was found in the cooling tower from this particular hotel in the Bronx. So as a result of this, New York City adopted this law, which requires registration, inspection, cleaning, disinfection, and testing of all cooling towers. And a documented management and maintenance plan must also be in place. Okay, what is this maintenance and management plan? We got to identify a program team. You know, your property manager, your chief engineer, your water treatment company, your consultant. Okay, you need the description of the water systems. Where does the water come from? Where does it go? Then you have to say, okay, what's the risk assessment of the building water systems? Do we have any showers in the building? Do we have any areas where there may be dead legs? What are we doing to prevent that? So monitoring systems and subsequent corrective actions. Confirmation. Is the program implemented as designed? And it's also important to, well, it is critical you document and communication. And that's what the DOH inspectors, I'm sure you guys know, go out to these buildings and they look for these records. Okay, so now the question is, should you test for this? In William Shakespeare's play Hamlet, Hamlet tells Ophelia, get thee to a nunnery, which means you better leave to escape corruption. Okay, so what does that have to do with anything? Next slide. Well, the property manager, to test and not to test, that is the question, which means don't get me in trouble with the tenants. Okay, so there's we just have to make sure that if we test, we're going to have corrective action. We have to have a plan for corrective actions. So as I indicated, there are no regulations for testing the drinking water. However, tenants need to know their water is safe. If you decide to test, be prepared for any positive results and be able to react to correct the situation and relay that corrective actions to the particular tenant. Okay? Testing frequency and locations. A lot of times buildings have Legionella testing as part of their indoor air quality. So besides testing the air and looking at the filters and looking at the airflows, they also test the domestic water maybe once or twice a year. You can also take random samples from each of the hot water systems, and we'll go into a few examples when we get to it. But let's say you have a building that has 2 hot water heating systems. You may want to take a sample at the top and the bottom of each system, just so you get a representative indication of if there's Legionella present. Okay. So what are some of the testing concerns? Well, as we all know, the hot water is tempered at the sink with cold water to prevent scalding. We don't want people getting 130-degree water at their hands and burning themselves. These sinks are also equipped with these IR sensors, which do not allow full flow and a time. So you'll see that in the next slide. So this is a typical New York City office. And you see we had to keep putting my hand there just to get the right amount of flow. Okay, so that's almost creating a stagnant water condition or a dead leg. What we typically see is this, and if you can read that, but that temperature on this particular case was barely got above 72 degrees in, I think, about 3 minutes. What we like to see now, this particular case, it was coming off the building's hot water system, and the building engineers did a really good job of creating this hot water loop where there was constant flow, and you can see there that the temperature was 125 degrees, maybe even a little bit too warm, but that's okay. Okay, so now we say we're going to be testing. Okay, so what are some of the acceptable levels in domestic water? Well, since there's no regulations, there are no acceptable levels. Okay, you may say that's crazy. However, various organizations indicate their respective guidelines. So there's a difference between a guideline and a regulation for these tests. So we recommend the AIHA guideline, which is the American Institute of Hygiene Associates, and we indicate that anything under 10 CFU, 10 colony forming units per ml is acceptable. Okay. The General Service Administration, the GSA, has their own guideline in which they target 0 CFU per ml. Okay, we'll get into that in a second. Just go back one slide also. I don't have in here, but also any of your properties that may have companies that from the UK, Scotland, or England, over in the UK, they have regulations that also say that they need to get 0 or below 0. Okay, next slide. So this is the AIH guideline, which is, this AIH put out this book. It may be hard to see, but recognition, evaluation, control of Legionella in building water systems. And basically, they're saying if you get 1 to 10, you can flush it, but it's not a health concern. If you get above 10, you should take more corrective actions. Okay. I wanted to put this slide in because, as I said before, I've been in the water treatment industry for over 30 years. And years ago, people used to say to me, Tom, do you want to test? Should we test for Legionella? I would answer the same way. If you want to test, you're going to have corrective actions. But people, before ASHRAE came out with any guidelines, the old guideline was this OSHA guideline. It was from Chapter 7 of the OSHA guideline. And OSHA at that point said, hey, anything under 10 is okay. However, nobody uses this OSHA guideline anymore. So I just wanted to put that in there, just how this is kind of obsolete. So corrective actions. So we're going to go through 3 cases where case 1 is the Class A building where one of the tenants, as I just mentioned, is a UK-based tenant. So this tenant had 5 sinks, 2 of which were supplied by the base building hot water to their bathrooms out in the common space. The other 3 sinks were supplied by a small 5-gallon hot water heater in the pantry ceiling. And the tenant wanted to follow UK regulations, which would say, hey, I want to have 0 CFU per ml or non-detect. Okay. So there's a little diagram of their system. You see the water comes in on the left side. That one box on the upper left is a coffee machine. And then there's a 5-gallon hot water heater, which feeds the ADA bathroom, primary sink, and a secondary pantry sink. Okay. All fed from that small 5-gallon hot water heater. All right. Next slide. And this is the slide. This shows the schematic of the water that's being sent to what we would call the common bathroom that this tenant uses, and it's being supplied by the building, which has a much larger hot water heater and feeds the women's room and the men's bathroom on that same floor. Okay. So what happened? Legionella tests were taken at their sinks supplied by the 5-gallon heater in the common bathrooms. The results from the tenant sinks showed positive results, at which time the building did corrective actions. So this small 5-gallon heater, it just wasn't enough to heat up the water in these 3 sinks. The other 2 sinks, the other common bathrooms, showed non-detectable levels. As when we measured some temperatures coming out of those sinks, the temperature was really very close to 120 degrees, and it was coming out of the hot water heater at 140. So again, that goes back to one of the slides there. It says, hey, where does Legionella grow? At 140 degrees, you're getting up there where you're almost killing it. And 120 degrees is, where was tempered at the sink so that people don't get burnt. Okay. Oh, so that customer, what they wound up doing was they wound up doing a chlorination. So they had a company come in, put chlorine into the system, flushed it out, and then retest. Okay. Unfortunately, it came back, so they went to something else, a final corrective action. But let's go to the next one. So this case 2 is a Class A building with a GSA agency as a tenant. And if you remember, I said GSA, they want 0, but they want employees to have access to safe drinking water. This includes drinking water supplied to fountains, sinks, showers, and pantries. So Legionella tests must be taken on hot water systems with results at 0 CFU per ml. Okay, so what did these results come back at? Like, well, I'll show you a diagram first. So you can go to the next slide, Tara. So here you see this building has 3 different hot water systems, a low heating zone, a mid heating zone, and a high heating zone. So we sampled in all of those different systems, okay? Next slide. So what the results were mixed. The results showed that the sinks and faucets that were further away from the base building heaters showed higher counts of Legionella. They use the term distal. So, if a hot water heater is on the 23rd floor and you're sampling on the 25th floor, that's furthest away from that hot water heater. Chances are that hot water temperature is not going to be the same as it was coming out of the heater, so that the chance for Legionella to grow there gets higher as you get further away from the hot water heater. Sinks that were close to the heaters and fed from a tenant supplied properly sized hot water heater had lower counts or counts that were non-detectable. Since the GSA required non-detectable levels, corrective actions were taken to remediate. It's very similar to the company that had the UK tenant in the building. This building happened to use chlorination and with the same results. Okay. So case 3, we have a Class A building with a GSA tenant as a tenant, a GSA agency as a tenant, and this actually is a live. We're going to invite Pat Dolan to give us his real life experience of what happened in his building. Pat?
All right, good afternoon, everybody. Again, Pat Dolan here from the DURS organization and the current chair of BOMA, New York. So back in May of 2024, we have a tenant, the GSA, who has about 5 floors at One World Trade Center. They had an incident in another location, and they created this mandate where they wanted Legionella testing at all either GSA-owned properties or any spaces that were leased that housed GSA agencies. So for us, we had Customs and Border, FEMA, Homeland Security. So these groups were in our building. So we, of course, got the request to do some water testing for them. Now, previous to this, we did some water testing, but we really just did it to comply with the Safe Drinking Water Act. So we didn't really test for Legionella in the building as far as domestic water, So we went forward and tested some floors within the GSA space, and lo and behold, we had a hit of Legionella. It was Legionella anisa. It's a different species. It's not the Nemophila that Tom had referred to, which is the more serious species. So we get these results, and we talked to the GSA folks, and we said, you know what, let us flush the systems, let's heat the water up, and we'll take some more samples and we'll do a retest. So we went ahead and took those steps, and then lo and behold, we had more positive hits. And then we took some more sampling elsewhere, and we quickly realized that we had a significant problem. So first order of business was, okay, this is a highly visible, iconic building. We need to have a discussion with our ownership, our leadership, our partners, our attorneys, our communications people. We got to get the word out because we're concerned that we might have a PR issue. So we go ahead and craft a message about what we're going to do. We engage people to help us with this process. We hire a consultant. First thing, we continued to test and get sampling. We were testing core restrooms. We were testing pantries, anywhere that we had water usage. And the GSA floors, they had quite a bit of showers because they had a gym. So we were doing some of that. When you have this issue now, what you will be asked to do is develop a water management plan on your domestic systems. So this is basically everything that you're going to be doing, all the various people who are involved, the building leadership team, your consultants, your vendors, the folks that are doing the sampling, all this pertinent information that goes into this management plan that needed to be developed. We really dug into our plumbing systems to really understand the distribution, all the risers, how tenant suites are being fed, what fixtures are being fed from what risers. This took quite a significant amount of work between building staff and some of our consulting engineers that we work with, as well as the consultant that we were working with on this Legionella issue. One thing that we got going right away, especially in showers and in the core restrooms, is we got point of use filters. There is product out there in the marketplace that you can install that will filter out Legionella. This is stuff that is approved and widely accepted, and so we went ahead and did that. And then we started to think about how much water we're using in the building. And our building, I'm sure no different than a lot of other buildings, the occupancy is down. So there's less people making coffee, washing hands, using the restrooms. I mean, the consumption in the building was quite low. Our building also was built with a tremendous amount of redundancy. We had massive house tanks, and then we had a redundant house tank. So we had an issue with what is referred to as water aging. We just had too much water. So we decided that it was prudent for us to drain a house tank and take it out of service. And then we really worked with our consultants to see what the appropriate level to have in a house tank would be. And we lowered those levels. We'd rather have the house pumps come on and bring in fresh water more often than have water sit in these tanks. Obviously, with the complexity of the building, the size of the building, we ended up establishing how we were going to treat this. And we ultimately agreed upon a chlorine feed station and how we were going to go about doing that. And just the way the building is laid out, we ended up having to install about 21 chlorine feed stations throughout the building. We had to do wet taps on risers. We had to install some electric, get this product in and get it up and running, and therefore start moving and circulating chlorine throughout the building. This was a pretty significant lift. We were testing along the time to see how the systems were taking the chlorine. And as Tom had alluded to, while some people might use the guidelines of 10, the government wants a non-detect or zero amount of Legionella. And I don't think most of the tenants don't know or care whether it's Legionella pneumophila or Legionella anissa or any other Legionella. They just hear the L word. So we were very, very concerned that, we get this problem, under control. So again, we ended up draining all these house tanks. We reduced the aging of the water. We also did something in the tenant space where we started to remove these 5-gallon hot water tanks where water could sit. And in lieu of these hot water tanks, we started to install these EMACs, which are these small hot water heaters. They're like a heat exchanger, for lack of a better word, where there's really no storage. And this, based on everything that we were hearing and our people that we were talking to, this would be a much safer application for us to do than have water sitting around in tanks. The only way we were going to agree to having a hot water tank remaining online is if, you had a cafeteria where you're doing lots of dishwashing, you're doing lots of cooking, and you're moving the water, using the water where the risk was extremely limited. And we did not really go around the building to remove all these point of use filters I referred to until we got these control ranges where they needed to be, which was basically zero, which took us some time. It was well into the summer before we really started to see the ranges that we needed to see. And it's been an ongoing process. I think that I suspect that we will be chlorinating water for the foreseeable future. I don't see any change in the protocol because I think for the type of tenants that we have in the building, many people are into technology and still have a very hybrid work schedule. So our occupancy kind of, Monday's okay, Tuesday, Wednesday's heavy, Thursday drops off, Friday is like a Saturday around here, and that kind of occupancy on our heaviest days, we're probably 55 to 60% of the occupants. So we just feel like this is probably something that we're going to be staying with for quite some time. The other element of this is flushing. We're flushing a lot. Our cleaning staff at night is in the tenant space cleaning, and they're running the pantry sinks for a period of time to just kind of move water around. And we're doing that every night that the staff is in the space cleaning. And then on the weekends, our engineers are blowing down cold water risers, flushing cold water risers, moving water around, trying to move chlorine up and down these risers to get circulated through the building. So it has certainly been uh, a challenge for us. There's been more maintenance, more tasks, more expense clearly on consulting, on testing, on the chlorination product that we're installing, and having this company come in and monitor and ensure it's all in the control ranges that we need it to be. But it's very, very significant. And, some of the other things that we've done in our building rules and regulations, we're not going to allow any new hot water heaters to be installed in the building other than EMAX unless you can really prove prove the need. And we would be doing lots of due diligence with the consultant engineers during the landlord comment period to ensure that, in fact, they really need the water. And testing continues all the time. We're constantly testing, getting samples to ensure that the water ranges are where they need to be. I would say that the thing we did with our tenants was to just be very upfront and honest and tell them what we were dealing with and what our plan was. We did this in a town hall setting more than a couple of times. We've done this with individuals. We had to get on a pretty significant call with Washington, D.C., with the GSA to get them comfortable that the plan that we had in play was quite effective and to make sure everybody was safe. So that was our story. So, now we are in March of 2025, and this has now become a routine maintenance issue for us. But again, it has increased our operating expenses, increased our maintenance tasks, and it's just something that we're constantly, on guard to make sure that we don't have any type of issue again in the domestic water systems. So that's our story. So Tom and Tiara, I'll turn it back to you.
You got it.
Thank you, Pat.
Thank you.
Well, Pat, that was fantastic. We really, to have the real life experiences and real examples is a real help here. And you'll see that in the following slides, a lot of stuff that Pat talks about is in the slides coming up ahead. So with that, let's just go to the next slide and you'll be able to see. So we talked about corrective actions. First action, flush, and more flush. Pat mentioned that, not only on the weekends, but also having your janitors and engineers flush dead legs or rises. It's a big help, okay? Thermal disinfection. Thermal disinfection basically means that what we're going to do, we're going to take that hot water heater and we're going to bring it up to maybe 140, possibly even a little bit higher than that. The problem with this type of corrective action is that it's still very laborious. You have to go to each individual outlet or faucet, make sure you get up to 120 degrees, then go to the next one, et cetera, to make sure you're trying to kill as much of the Legionella that may be in those lines as possible. Chemical disinfection can either be a one-time shock of the hot water system, just like you shock a swimming pool, or a long-term online control system like Pat has his buildings. Basically, there's it's almost like a water treatment system where it reads something and then an automatic pump comes on there and adds chlorine into the hot water system. So these are different options. But okay, next slide. So long-term solutions we just mentioned, commercially available that help minimize Legionella in hot water system. Instantaneous hot water heaters. Again, Pat mentioned that. The building that I mentioned that had the UK tenant in that, they wound up putting in 3 of these hot water heaters right in those specific bathrooms rather than getting a larger hot water heater. They put one in each individual bathroom. Another methods are called copper silver ionization, online chlorination that Pat mentioned, chlorine dioxide, and chloroamine treatment. All of these are methods to basically try to kill the Legionella in the water. Chloroamine is a system that's very, very popular now. It's used really extensively in a lot of hospitals in New York City. Again, because as I mentioned before, the hospitals need to test and have a plan in place to make sure that people who are in the hospitals who are weak and have weak immune systems don't contact Legionella. So chloroamine is one of the systems that are used. Finally, as Pat mentioned, there are inline filters, or otherwise called point of use, that attach to the aerator and its particular sinks. Okay. Here's an example of what one of the ones that Pat was talking about. Basically, you bring hot water, you cold water in one outlet on the left side, and you have hot water coming out the right. And there's a thermostat on the side there, and these things are commercially available for you guys to purchase. As this example is online chemical treatment. This one happens to be the chloroamine system, but basically it improves the quality of the potable water and minimizes the growth of biofilms that promote the growth of harmful waterborne pathogens. Okay, and here's an example of that point of use filters. Now, this particular faucet has what we would typically call a gooseneck, but in some of your faucets in your office buildings, you don't have that much clearance. So that you can see that filter probably is about 4 inches in length. So you try to put that at the end of a faucet. There's not going to be much room for a person to get their hands underneath that sink to try to get the action. One other disadvantage about these point of use filters is they tend to get very dirty. So a lot of people put pre-filters before them to try to make them last a little bit longer. Pre-filter may be cheaper, just so that you try to remove some of the gook before it gets to that point of use filter. But these are very, very effective in minimizing Legionella. Okay, now we're going to talk about any further regulations. So we talked about ASHRAE 188, 2018, and it's basically, it's a guideline. And to establish minimum Legionella risk management requirements for building water systems. It applies to human-occupied commercial, institutional, multi-residential, and industrial buildings, excluding single-family homes. So I hope one of the questions may come up, should I test for Legionella in my hot water system at home? Probably not. But the intended use is basically building owners and managers, as well as individuals involved in design, installation, and Pat was talking about that. You have to get your engineers involved when there's a new tenant coming in, just so you have that, you want to try to minimize the risk of Legionella in that particular space. Okay, next slide. So Pat talked about also domestic water safety plan. So what is a domestic water safety plan? Though not required again, yet other than healthcare facilities, a management plan will help you stay on course. It's like a playbook. NFL teams have a playbook. Well, a water management plan is a playbook for minimizing Legionella in the building. Just like a cooling tower plan, it has a risk assessment of the water from the time it enters into your building until it exits. Okay, next slide. So this particular publication is put out by the CDC. There is a link on the bottom there, but this was put out in 2016. It says, hey, how do I develop a water management program to reduce Legionella growth in the building? And it actually takes you through step-by-step answers, yes or no, yes or no. It shows you how to develop a little flow diagram, and then we'll get into the specific what's involved in the other items in the plan. Next. So what is a water management plan? You establish a team. Like I mentioned before, the property manager, the chief. You might have a nurse or a healthcare professional on site. Your plumber would be a good person on that. Determine water system goals. Well, do we want to go for 10? Do we want to go for 0? That's all important to put down in this plan. We want a survey, description, and flow diagram of water in the building. Okay, water comes in this way, goes up to the 23rd floor, turns around, comes back to the heater. Whatever the system is, it's just good to know. You have up-to-date as-built drawings for any plumbing systems, and that they're accurate. How many times you go into a building and say, oh, that drawing doesn't make sense because the change was made there 4 years ago. So it's important to try to keep the water flow diagrams up to date. Then perform hazard analysis. Where are our risks? Is there a cooling tower in our system? Is there any showers? As Pat mentioned, a gym at a facility. Is there any hot tubs? I don't know any office buildings, but maybe there are. And then we have to figure out a strategy for risk minimization. What's our testing plan? Where we got to test and how often? Then we have to verify it. We're doing what we said we will do. Okay. Basically making sure that, you say what you got to do and do what you say. Okay. Next. Strategies for risk minimization. We want a testing plan, locations and frequencies I just mentioned. And are we doing what we said? Monitoring and testing water for pH, chlorine residuals. So this is kind of important, temperatures and logging that data. Hey, we take a sample of the water coming into the building. Well, it's supposed to be between 0.1 and 1.0. Well, if you have less than that, you really can't call up the city and say, hey, I'm not getting good chlorine levels, because they're going to tell you to, hang up the phone or something. But what's important is that you keep records of that so that you know that, hey, with it not a good chlorine residual in my system, there may be a future concern. Okay. And same thing with temperatures in your hot water systems. If your water's coming out of a hot water heater at 140 degrees, but you test, at a distal spot, you're only getting 95, that's telling you there's something that you may need to take a look into. And validation, is the plan working? So some of the key takeaways as we kind of put this to the end, factors to consider, and I think Pat, you did a great job of explaining some of the things. How is water used in your building and the temperature fluctuations? The point of use by occupants, especially for showering or consumption. Any past problems with the plumbing system, as I mentioned before, as-built, stagnation, dead legs, pressure swings. Even sometimes we've had buildings where they're doing some work outside on the water main coming into the building. Sometimes that work will actually upset some of the junk that's in that water, and you may have a higher chance for Legionella coming into the building. Previous Legionella, and consider proactive inline measures, as we, as Pat indicated, we went over the 3 possible systems you can use for corrective actions. But again, the big thing is for one of the key takeaways, and I should have put this in there, is that, for Legionella, it could come into your building, but it needs to grow. It needs to grow in a temperature range, and then it needs to be aspirated, or it needs to, the only way you can get that is through a aerosol. So just make sure if we try to, get an understanding of, how we minimize that risk, we all can be in better condition to, minimize Legionella in the building. So, but that's about it. So now we'll take any questions if there's any questions come up. Saunas. That's a very good question, Greg. Saunas basically is steam. So, the temperature of the hot water of the steam is probably so hot above, it has to be, if it's steam, it has to be above 212 degrees. So chances are no, not a sauna, but a hot tub, yes, because you're sitting in a hot tub and it's all splashing and, you have the mist coming up. That's more of a risk in a hot tub than in a sauna. Anything else?
Any other questions? Again, you can use the questions feature in the upper right-hand corner of your screen to ask, or you can drop it in the chat. Yes, we will be sure to share the recording and the presentation deck.
Guys, easy. I can't even look at it. It's very unusual to be talking to a screen instead of talking to 33 people or 34 people, whatever it is, But thank you for your time, and really appreciate it. And again, if you have any questions, will my contact be on there?
Yes.
Okay.
Yeah.
Yeah, you'll find a way. This is not a sales presentation, but if you have any comments, please feel free to contact me. We can have a conversation. So thanks everybody for your time. I really appreciate it. Have a great day.
Thank you, everyone.
Okay, thanks.
Have a great day.